Hey everybody, this is Mrs. Dinkelman, and we are going to finish up the notes from the Riemann sums and talk about how to do trapezoids. So the midpoint probably was supposed to go in this part too, but I went ahead and did it on the previous video. So if you haven't watched the midpoint yet and you want to learn about that, go ahead and look at the last video. Just fast forward to that midpoint toward the end. We're going to talk about how trapezoids can be used to approximate the area under a curve. Sometimes they're better just because they can match the increasing, decreasing nature of the curve, which can kind of make it so we don't have so much of an overestimate or so much of an underestimate. You can see by looking at the picture here, most of these are pretty good. The last one is maybe a little bit off. Okay, so a couple of things. First of all, it is important to commit this area formula to memory. If you're anything like me, I was able to kind of get away without finding the area of a trapezoid using that formula, at least in like algebra geometry class, because I could just cut the trapezoid into like a rectangle and a triangle or a rectangle and two triangles. In this case, that's not always going to work. So it is important that you commit that to memory if you don't have it there already. The other thing is kind of look at the picture of these trapezoids that we're talking about. You can see there with the blue one, that's the specific kind of trapezoid we're talking about, and it is on its side. So it's not the kind with the two triangles on it, just the one triangle on the side, and then kind of that straight on that other side. And then again, it's kind of tipped so that it's really sideways in my mind. The way we're going to find out what that base 1 and base 2 are going to be is basically the y-coordinate, because the y-coordinate is going to tell us how tall that base goes up to. Okay, and since we're starting at the 0, that's going to tell us the height here. Okay, on this first example, I'm going to write a bunch of notation. We will jump to our calculator, and I'm going to show you a few quick shortcuts we can do if we have the intervals that are equal, which we do in this case, and then we'll do one from a table where they're not. So in that case, we'll have to work a little bit harder, although we won't have to use our calculator, I don't think. Okay, I like to think about what our delta x is first. So our delta x here is going to be a half because we're going 2 spaces but 4, so we're going to divide it into 4 places. That delta x is really the height here. And think about that, it's on its side. So the other thing I like to do is think about what the intervals are. Since I'm going by halves, this just helps my brain a little bit. I don't know if it helps yours, but I'm going to write it for myself. I like to think about what those intervals are. So for this first trapezoid, I'm looking up here at the formula again. So it's 1/2, and then base 1 and base 2. Remember, the way we're going to find the base 1 and base 2 is the y-coordinates. So right now, because I don't want to jump back and forth too much, I'm going to just write in what I'm going to have to find is what the y-coordinates are to find base 1 and base 2. And then times the height, which is the delta x. So for all of these, that is going to be a 1/2. So we can kind of see some patterning maybe that we're going to be able to kind of make a shortcut a little bit. Second trapezoid, so 1/2, base 1 plus base 2. Again, the way we're going to find base 1 and base 2 is by finding the y-coordinates, and then the height is a half. And I'm just going to continue on here. Third trapezoid, 1/2, and then base 1 and base 2. And then the height is a half. And then the final trapezoid, 1/2, base 1 and base 2 times the height. Sneak in that 1/2 there. Okay, I'm going to jump to my calculator in just a minute, but before we do that, let's talk about some things that might make our life easier so we don't have to click a bunch of buttons. So notice all of these have a 1/2 just because the formula has a 1/2 in it, so we could factor that out. They all also have the same height, or delta x, so we could actually factor that out as well. One more thing I want you to notice is that I have like f of 1/2 twice, and then f of 1 twice, and then f of 1/2 twice. The end ones I don't though, and let's think about what that means visually. So come back up here and look at the green trapezoid. So it makes sense that the end ones, we only use those once, but the in-betweens, okay, yeah, those touch 2 trapezoids. It's the base for one and a base for the other. So I'm just going to rewrite this a little bit because I think I can make my life easier when I get to my calculator. So there is an f of 0. There are two f of 1/2s, two f of 1s, two f of 1.5, and then just one f of 2. Now, I made this video earlier, but the sound wasn't working, so that was a bummer, but it's already kind of on my calculator. So first thing, I like to put the function up there in the y1 so that on my home screen, it's just a little easier to type because I can just do the y1 ofs. So what I've done here is I have a 1/4 on the outside for the 1/2 times 1/2, and then y1 of 0, 2y1 of 0.5s, 2y1 of 1s, 2y1 of 1.5s, and a y1 of 2. And so I got 4.75. Okay, just kind of a by the way, on those ones where we kind of have an equal distribution, like an equal delta x or y, technically the trapezoid is equal to the left and right averaged. Okay, so if we average the left and right, we get the trapezoid, just by the way, which makes sense to my brain because the formula for the area of a trapezoid is just averaging the heights of the two sides. Okay, this next one we're not going to be able to do too much shortcutting because the widths here are not equal. The other thing is we're looking for an approximation for velocity based on the acceleration. And unfortunately, our velocity doesn't start at 0, 0. So we kind of have like a head start in our velocity that we'll have to make sure that we add in to our answer at the end. Don't let me forget that. Okay, so the trapezoids we're going to do are going to be the 0 to 2, 2 to 5, 5 to 7, 7 to 8. Again, the width between all of those t coordinates is not the same, so it's just more helpful, I think, to just kind of follow through with the formula. So 1/2 base 1 plus base 2. Remember, our bases are our y coordinates. So base 1 plus base 2. And then the height, or the delta x here, is a 2. The next one, 1/2 base 1 plus base 2. Again, those are the y coordinates, in this case the a of t's. And then between 2 and 5, the height is 3. Third trapezoid, 1/2 base 1 plus base 2. Again, times the height. And then the final trapezoid, 1/2 base 1 plus base 2 times the height. Now, we could factor out the 1/2 because they all have that, but we can't double up and do that like there's two 4s here because this 4 gets multiplied by 3 and this 4 gets multiplied by 2. So really taking the 1/2 out would be the only kind of shortcut I could do here if I wanted. Okay, first one, the 2's cancel, so that's just a 4. This next one, 17 times 3 is 51. So 51 halves. This one, the 2's cancel. So we're just left with 13 plus 21. So 34. And then finally, this one is 44 divided by 2, which is 22. So let's see what that is. So 4 plus 34, 38 plus 22 is 50. How about 60? Hopefully you guys were going to catch me on that. Okay, so 60 plus that 51 halves. And I'm just going to treat that like a mixed number. So 60 times 2 is 120, so 171 over 2. That's the answer to the trapezoidal rule. But remember, we have this starting location of 3. So what we really need to do is say, okay, we're trying to do 3 plus what we got there. I'm going to treat 3 like 6 halves. And we don't really have a label because they didn't give us any units earlier. Okay, so now you should be able to kind of finish this assignment, which we kind of have put 6, 7, and 6, 8 together. So you just need to get to 6, 8 and finish those up. There are probably some midpoint ones on there as well.